Binomial distribution and introduction. I am A. Mohan Kumaravelu, Assistant Professor, Department of Science and Humanities, Nanda College of Technology, Erode. Here, we following contents are discussed. The topics are introduction, what is binomial distribution, definition of binomial distribution, assumption of binomial distribution, problems, conclusion. Introduction to the binomial distribution. Binomial distribution was discovered by James Bernoulli in 1738. That this is a discrete probability distribution. A discrete probability distribution applicable to the scenarios where the set of possible outcomes is discrete, such as coin toss or a roll of dice, can be encoded by a discrete list of the probabilities of the outcomes known as a probability mass function. Definition of binomial distribution. If X is a discrete random variable with a probability mass function, binomial distribution formula is P of X equal to NCX P power X into 1 minus P whole power N minus X, where X equal to 0, 1, 2, 3, etc. N and Q equal to 1 minus P, then X is a binomial variate and the distribution of X is called binomial distribution. What is binomial distribution? The word binomial literally means two members. A binomial distribution for a random variable X, known as binomial variate, is one in which there are only two possible outcomes, success and failure, for a finite number of trials. Note that however we define success and failure, the two events must be mutually exclusive and complementary. That is, they cannot occur at the same time, mutually exclusive, and the sum of their probabilities is 100% complementary. Here we discuss the binomial distribution expression. P of capital X equal to Xe equal to NCX P power X into 1 minus P whole power N minus X. X is a random variable, P probability of success, 1 minus P probability of failure, N minus X number of failures, C combination of X success from N trials, small x number of success, where P comma Q should be less than 1, where P comma Q should be less than 1. P plus Q must be equal to 1 because the probability cannot be more than 1. If X is a discrete random variable which may take on only countable number of distinct values such as 1, 2, 3, 4. Assumption for binomial distribution. For each trial, there are only two possible outcomes on each trial, S success and F failure. The number of trials in N finite. For each trial, the two outcomes are mutually exclusive. Probability of S equal to P is a constant. Probability of F equal to Q is equal to 1 minus P. The trials are independent. The outcomes of trials are not affected by the outcome of any other trial. The probability of success P is constant from the probability of success P is constant from trial to trial. Problems. Example. Here we take a problem. Example 1. A quiz contest of 10 multiple choice question. Each question has 5 possible answers. Only one of which is correct. Pat plans to guess the answer to each question. Find the probability that P at gets A. One answer was one answer correct. B. All 10 answers are correct. Solution. N equal to 10, P equal to 0.2. P of 1 equal to 10 factorial divided by 1 factorial into 10 minus 1 factorial into 0.2 power whole power 1. 1 minus 0.2 whole power 10 minus 1 equal to 10 into 0.2 into 0.8 whole power 9 equal to 0.2684. B. probability of 10 equal to 10 factorial divided by 10 factorial into 10 minus 10 factorial into 0.2 whole to the power 10, 1 minus 0.2, 10 minus 10 equal to 1 minus 0.2 the power 10 into 10 equal to 0.000001. Here we also another problem discussed. Example, the probability of that a baby is born, a boy is 0.51, a midwife delivers 10 baby, find first question A. The probability of that exactly 4 are male. B. Probability that at least 8 are male. Probability of x equal to 4. 10C4 into 0.51 to the power 4 into 0.49 to the power 6 equal to 0.197. Answer B. Probability of x is greater than or equal to 8 equal to P of x equal to 8 plus P of x equal to 9 plus P of x equal to 10. That is equal to 10C8 into 0.51 to the power 8 into 0.49 to the power 2 plus 10C9 into 0.51 power 9 plus into 0.49 plus 0.51 to the power 10. That is equal to 0.04945 plus 0.01144 plus 0.00119. That is sum of the value 0.0621. And the example 3. In a college, 20% of students are girls. In a random sample of 5 students, find the probability that there are 2 girls. Solution. Let x be a binomial variate denoting the number of girls with parameters n equal to 5, p equal to 20 by 100.2. P of x equal to x, ncx, p power x, q power n minus x. P of x less than or equal to 2 equal to P of x equal to 0 plus P of x equal to 1 plus P of x equal to 2. That is equal to 5C0 into 0.2 into 0.8 whole to the power 5 plus 5C1 point to the power 1 point to the power 4 plus 5C2 point to the power 2 into point to the power 0.8 to the power 3. That is equal to 0.32768 plus 0.4096 plus 0.2048. That is sum of the value 0.94208. Conclusion. The binomial distribution is a discrete problem distribution used when there are only 2 possible outcomes for a random variable, success and failure. Success and failure are mutually exclusive. They cannot occur at the same time. The binomial distribution assumes a finite number of trials n. For the binomial distribution to be applied, each successive trials must be independent of the last. That is, the outcomes of a previous trial has no bearing on the probabilities of success and subsequent trials. For example, a new drug is introduced to cure a disease. If either cures the disease, it is successful, or does not cure the disease, it is failure. If you purchase a lottery ticket, you are either going to win money or you are not. A machine is known to produce average 2% defective components. As an engineer, you might need to know the probability that 3 items are defective in the next 20 items produced. Basically, anything you can think of that can only be success or failure can be represented by a binomial distribution. Thank you.